Now we are going to discuss acceleration of electrons when the ends of the conductor is connected to a voltage source. So this is my conductor. Large amount of free electrons are there inside the conductor. Ends of the conductor is connected to a source of EMF, which provide potential difference V across the ends of the conductor. Then there exists an electric field across the ends of the conductor, and the amount of electric field we already studied, that E is equal to minus of V by L. Now look at each electron. Each electron is now inside an electric field. An electron inside an electric field experiences a force, and that force F is given by minus of E into E. So under this force, the electron drifts against the electric field. Now one more equation, the equation for force is given by F is equal to ma. This is according to Newton. So we got two equations for the same physical quantity force. Let us equate them together. Ma is equal to minus of EE. Therefore A is equal to minus of EE by M. So this gives the equation for acceleration of the electron under the electric field. Now the acceleration of the electron is directly proportional to electric field. More the electric field, more will be the acceleration. Acceleration of the electron is opposite to electric field. That is what this negative sign indicates. Now this acceleration of electron exists only in between two successive collisions, or the effect of acceleration is visible in between two successive collisions. Now let us discuss something about motion of electron inside a conductor. Motion of electron inside a conductor, even if a potential difference V is applied across the ends of the conductor, is not linear. The motion of electron is opposed, because as the electron moves through the conductor, it collides with neighboring electron as well as it collides with crystal ions. If there are n free electron, there will be n positive ions also in the conductor. Now, and as soon as it suffer a collision, it deviates the path, and again it suffer another collision, again deviate the path. So the motion will be like this, a zigzag one, but it constantly drifting against the electric field with an average velocity called drift velocity. Now the acceleration of electron obviously exists between two successive collisions only. So let us assume that electron is accelerating from initial velocity 0. It is accelerating and acquire a final velocity Vd, an average final velocity, just before it suffer another collision. Now the time taken for acceleration, or average time of acceleration, is called a relaxation time. It is nothing but average time interval between two successive collisions. Some collision may take less time only, some collision may take more time, but an average time is defined, and that is called relaxation time. Relaxation time is the average time interval between two successive collisions, or relaxation time is the time for which electrons are accelerated. Now let us apply this particular thing: initial velocity 0, final velocity Vd, acceleration A, and the time taken tau in first equation of motion. We all know that first equation of motion, final velocity is equal to initial velocity plus acceleration into time taken. In this case, final velocity is the average velocity of the electron just before a collision, and that is the drift velocity, is equal to initial velocity 0 plus acceleration into relaxation time tau. Since initial velocity 0, let us substitute A. What is A? Already we studied A is equal to minus EE by M, and also initial velocity 0, therefore Vd can be written as minus of EE by M into tau. So this equation gives the equation for drift velocity. So the definition of drift velocity is written over here. The drift velocity is the average velocity with which an electron drifts against an electric field when the ends of the conductor is connected to a source of EMF. The negative sign in the drift velocity indicate that electrons are drifting against the electric field. As more electric field is given, more will be the drift velocity, but always the drift velocity will be against the electric field. So the motion of electron inside a conductor is not an infinitely accelerated one. It is not just like a freely falling body whose velocity increases gradually. But electron motion cannot be considered as a uniformly accelerated one. Yes, of course, acceleration is there in between two successive collision. Its motion can be considered as a constant velocity or uniform velocity, and that uniform velocity is called drift velocity. Now let us consider another equation, that is equation for electric field applied, and that will be equal to minus of V by L. Put as equation number 3, that equation is substituted in equation number 2, then drift velocity equation can be written as Vd is equal to E by M into V by L into tau. From this equation, it is very clear that Vd proportional to V, where V is the applied voltage and Vd is the drift velocity. So more voltage is given, more will be the drift velocity. Now one more term I want to explain, and that is the electron mobility. Mobility of the electron is defined as the drift velocity acquired per unit electric field. Drift velocity per unit electric field is called mobility of electron. So mu E is equal to Vd divided by E. What is the meaning of that? More drift velocity is acquired when less electric field is given, that means mobility is more. If less drift velocity only acquired for a given electric field, that means mobility is less. Anyway, drift velocity divided by electric field is the electron mobility. So I can substitute drift velocity, magnitude of the drift velocity over here. So that is E by M into tau. Then E and E cancels. Mobility mu E is equal to E tau by M. And you can find out by substituting the unit of Vd and unit of E. Unit of mobility is meter coulomb Newton raised to minus 1, second raised to minus 1. As well as another unit is there in SI, meter square, second raised to minus 1, volt raised to minus 1. So this is what electron mobility. Now another thing we have to study is the relation between electric current and drift velocity. When the ends of the conductor is connected to a source of EMF, electrons start drifting against the electric field in a particular direction, that is against the electric field towards the positive plate of the battery, and this bulk movement of electron constitute a current. So this is the conductor, ends of the conductor is connected to a voltage source, there exists an electric field. When there is an electric field, electron drifts with a velocity Vd. Since electrons are drifting like this, there exists a current I. So there is a relation between current and drift velocity. That is what we are going to derive. Let us consider length of the conductor is L and area of cross section is A. General equation for electric current I is equal to Q by T. Let us substitute, put it as equation number 1. Now what is Q? The amount of charge passing through the conductor, and amount of charge passing through the conductor can be written as N into E, where N is the total number of electron present in the conductor and E is the charge of one electron. N is the total number of electron present in the conductor, E is the charge of one electron. Now let us assume that small n be the number density of free electron. What is meant by number density of free electron? Number density of free electron means number of electrons per unit volume. So small n is equal to capital N total number of electron divided by capital V, where capital V is the total volume. Since it is a cylindrical conductor, capital V can be written as area into length. So small n is equal to capital N divided by area into length. From this equation I can find out capital N is equal to small n into area into length, where small n is the number density of free electron. Put as equation number 3. When I substitute equation number 3 in equation number 2, I will be getting total charge passes through the conductor, and the total charge passes through the conductor Q is equal to N into A into L into E, because capital N we already obtained NaL, and I am substituting over there, then I will be getting Q is equal to N into A into L into E. This is the amount of charge passes through the conductor in a given time. Now let us assume that the electrons are moving with the drift velocity. Electrons are passing through the conductor with the drift velocity, and they are crossing the conductor of length L. And let us assume that t is the time taken to cross the conductor. Then the drift velocity equation can be written as length divided by time. This is a general equation for velocity, length divided by time. Since Vd is equal to L by T, I can write T is equal to L by Vd. Put as equation number 5. So equation number 4 gives me the total charge present in the conductor. Equation number 5 gives me the time taken by these charges to cross the conductor. So I am going to substitute this equation number 4 and equation number 5 in first equation, equation number 1, I is equal to Q by T. Equation number 4 gives me Q and equation number 5 gives me T. Then when I substitute that, I will be getting I is equal to NALE divided by L by Vd. So L and L cancels and I is equal to NAEVd. So this is the relation between drift velocity and electric current. So it is very clear that I is proportional to Vd. What is the meaning of that? As Vd increases, electric current also increases. As drift velocity increases, electric current increases. So let us summarize this. Electric current increases with the drift velocity, and the drift velocity increases with electric field across the ends of the conductor, and electric field across the ends of the conductor increases with applied voltage. As the voltage increases, electric field across the ends of the conductor increases, because E is equal to minus V by L. As the electric field across the ends of the conductor increases, drift velocity increases, because drift velocity Vd is equal to minus E by m into tau. As drift velocity increases, electric current increases, because electric current I is equal to NAEVd. So students, this is the mechanism of current flow through a conductor.